lesson is over decimals and fraction conversion. Let's go over our do now, over dividing integers. Over the past 7 days, Mrs. Cho found that the temperature outside had a drop of a total of 35 degrees. Determine the average change in temperature each day. So drop of 35 is represented by the integer of negative 35 degrees. And it took 7 days for it to drop. So it wants to know what is the change in temperature each day. So there's 1 day. How do you break down 7 days to 1 day? You break it down by dividing by 7. If you have 35 negatives and you need to break it down into 7 groups, 5 negatives per day. If you forgot to multiply and divide integers, use the tic-tac-toe thing. A negative with a positive becomes a negative. So today we're going to talk about another word called rational number. A rational number is any number that can be written as a fraction or a ratio, which we'll be discussing shortly. So anything that can be written as a fraction. So a whole number can be written as a fraction. 5. 5 can be written as 5 divided by 1. You just put a 1 below it. Because what's 5 divided by 1? 5. It doesn't change its value. 1 could be written as 1 divided by 1. 14 can be written as 14 divided by 1. An integer can be written as a fraction also. So what's an integer again? A positive or negative whole number. So negative 6 can be written as a fraction. Negative 6 divided by 1. 12 can be written as a fraction. 12 divided by 1. Negative 24 can be written as a fraction. Negative 24 divided by 1. Last but not least, a decimal can be written as a fraction. We're going to actually teach that today. 0 and 8/10 is the fraction. 0 and 21/100 is the fraction. So here is a chart. Is it correct? A whole number, 38.5 and 35/10 is not a whole number. Whole number is positive. Nope, not negative 7. So these are the whole number. Those are the correct. Next one, integers. Integers are positive, negative whole number. This is not correct. That's a fraction. This is a decimal. Everything else here looks like positive, negative whole numbers. So rational numbers are anything that can be written as a fraction. Negative 4 and 7/10. That can be written as a fraction. That's a fraction. Can negative 2 be written as a fraction? Negative 2 over 1 divided by 1. 5 can be written as a fraction. 5 divided by 1. 3/4 is a rational number. 3 and 5/10. That's a fraction. Negative 7 divided by 1 is a fraction. And 9 and 75/100 can be written as a fraction. So those are all rational numbers. Can anything inside a whole number be written as a rational number? Yes, they all can be written as a fraction. So everything in a whole number are integers, and everything in a whole number of integers are rational numbers. So which set of number does negative 87 belong to? Negative 87 is a negative whole number, so it's an integer. Can it be written as a fraction? Yes, it can. So it's a rational number, not a whole number. 0. 0 is a whole number. It's also an integer. Can it be written as a fraction? Yes, it can. Can you do 0 divided by 1? Can you have 0 stuff and divide it into one group? Each person gets 0 stuff. What about negative 5/16? That's not a whole number, so it's only a rational number. It can be written as a fraction. What about 52? 52 is a whole number, it's a positive, negative whole number, and it's a rational number because you can write it as a fraction, 52 divided by 1. Number 5, which of the following numbers is an integer? An integer is a positive or negative whole number. The only one I see a whole number, a positive, negative whole number, A. Which of the following is not a whole number? Whole number or positive, this is an integer. So that is not, negative 4 is not a whole number, it's an integer. So now that we understand that a little better, let's learn how to turn decimals into fraction. Do you remember your place values from elementary school? That's going to help you. So let's look at the first one, 0 and 7/10. So I fill in 0 and 7. Do you remember place value tenths, hundreds, and thousands? So it's 0 and 7 is in a tenth. So when I say that 7/10, it sounds like a fraction of 7/10. This is the fraction equivalency for this decimal. Next one, 0 and 35 hundredths. So 35 hundredths. And this is the fraction equivalency of this decimal. Did you know you can simplify this fraction? You can break it down by dividing by 5 and get 7/20. So 7/20, 3500, 0 and 3500 are all equivalent. Next one, 4 and 25 hundredths. Can you break this down and simplify it? Yes, you can. Divide both the numerator and denominator by 25. You have 4 and 1/4. 4 and 34 hundredths. Ooh. So you can write that as a fraction, 4 and 4 hundredths. Can you break this down? Yes, you can divide both the numerator and denominator by 2, and you get 4 and 17/50. All right, so that's how you turn a decimal into a fraction. Use your place value. Sometimes you have to simplify it, sometimes you don't. What happens if you have to turn a fraction? All right, here are some more examples of decimal and fraction. So 7/10, 55 in hundreds, and 125,000. You have to simplify. 4/10, 35 hundredths, 625,000. Simplify it. 9 and 8/10, 7 and 15 hundredths, and 6 and 875,000. You have to simplify it. 12 and 6/10, 2 and 85 hundredths, 3 and 625,000. You have to simplify it. So what if you have now? How do you turn fractions to the reversal? Fractions to decimal. Imagine you have $4 and you want to split it evenly among these 5 friends. Unhappy man or boy. How much will each person get? If I have $4, 1, 2, 3, 4, and I want to split it evenly, so I have $4, and I want to divide it evenly among 5 friends. So $4 divided by 5 friends. Let's see, $4 divided by 5. Can 5 go in 4? 0 times. How many 5s? Oh, forget the decimal point. Line it up. How many 5s go in 40? 8 times. How many 5 go in 0? 0. So each person will get 80 cents, 80 cents, 80 cents, 80 cents, and 80 cents. So if I have $4 and I want to divide it among 5 friends, each person will get 80 cents. I would like you now to find the equivalent decimal for the fraction 4/5. Before you sit here and say to yourself, you can't do it, I don't know how to do it. Guys, we just did it. You have $4 and you're dividing it into 5 parts. 4/5 is the same as saying you have 4. This little line here, this bar means divide. You have 4 divided into 5 parts. Look right there. 4 divided by 5 parts. So you have 4, you're dividing into 5 parts. Look right there. Right? Yeah. So it's the same problem. 4/5 is the same as 4 divided by 5 and 4 divided by 4 divided by 5. So it's all the same problem. So you do know how to do it. So don't say you don't know how to do it. Some kids get tricked by these. I've seen in the past where they can't figure out which number goes inside the division bar and which one goes outside. This is how I memorize it. It's called typo. It means top number goes in, bottom goes out. If this can help you out, this mnemonic can help you out, then use it. But I don't use. Well, honestly, I do use that as an adult. You have 4, you're dividing into 5 parts. 4 divided by 5 parts. But if you need to use this little hint to help you, use it. All right, next one. You have $7. I want you to divide it split it evenly among 4 friends. So I have $7. I want to split it evenly among 4 friends. How much will each person get? So $7 divided by 4 friends. How many groups of 4 go to 7? 1 time. Remainder is 3. Bring down to 0. Don't forget to put a decimal point there. How many groups of 4 go in 30? 7 times. The remainder is 2. Bring down to 0. How many 4 going 20? 5 times. So each person gets $1.75, $1.75, $1.75, and $1.75. So, what is the decimal equivalency for this improper fraction, 7/4? Before you sit there again and say, I don't know how to do it. We just did it right here. 7 divided into 4 parts. Blah, blah. $7 divided by 4. Same. So you do know this. Again, if you get tricked, you can use something word called typo. Top number goes in, bottom number goes out. So for example, if you have the fraction 3/4, it really is 3 divided by 4, or it could be written as 3 divided into 4 parts. So it's 75/100. Let's practice now. We have 1/8. This is 1 divided by 8, or 1 divided into 8 parts. Or if that's confusing, use typo. Top number goes in, bottom goes out. So can 8 go in 1? No. Add a 0.0. Did you know, why do you add a 0.0? Did you know 1.0 does not change the value of this 1? So that's why if you add extra zeros here, make sure you add a point so it doesn't change its value. Now bring down 0. How many groups of 1 go in 10? 1 time. 2 is the remainder. Add another 0, bring it down. This is 1.00, it doesn't change its value. How many groups of 8 go to 20? 2 times. Remainder is 4. I need to get rid of the remainder. We don't do remainders in 6th grade. How many groups of 8 go to 40? 5 times. So we have the decimal of 0 and 125,000. It's the same as 1 divided by 8, or 1/8. Next one, 5 and 3/25. This fraction can be written as 3 divided by 25, or 3 divided to 25 parts. So can 25 go to 3? Nope. Add a 0.0. It does not change its value. Can 25 go to 3? 0 times. Forget decimal. Can 25 go to 30? 1 time. Remainder is 5. Bring down to 0. How many groups of 25 go to 50? 2 times. So we have the decimal equivalent, the fraction becomes 1200. So 5 plus 3/25 is the same as saying 5 and 1200ths, or 5 and 1200ths. 1/3. 1 divided by 3. 1 divided into 3 groups. Can 3 go in 1? 0 times. Add a 0.0 to get rid of the remainder. Again, it doesn't change its value. How many groups of 3 go in 10? 3 times. 1's the remainder. Add another 0. How many groups of 3 go in 10? 3 times. Wait, isn't this repeating? If you notice that there's a pattern here, you don't want to keep on doing this over and over. Just draw a repeating bar above it. This says 0 and 3300. It keeps repeating. This is a repeating bar. When I went to Ollie Middle School in A-Leaf as a 6th grader, my teacher, Mrs. Godows, I remember her, she made us draw little arrows at the end. Because it's a repeating bar, it means it keeps going forever and ever. So it's really 0.3333333333333333. So, but I'm not going to draw this repeating bars the arrow, because I know I can just draw a repeating bar. So the equivalency of 1/3 is 0 and 3300ths for the repeating bar. 2/9. This is the same as saying 2 divided by 9, or 2 divided into 9 parts. Can 9 go in 2? 0 times. And a 0.0. Can 9 go in 20? 2 times. Oh, forgot to bring a 0. Can group of 9 go into 20? 2 times is 18. 20 minus 18 is 2. Add another 0, bring it down. Can 9 go into 20? 2 times. Isn't this repeating? It is. Don't forget the repeating bar. So the equivalency to 9 is 0 and 2200 with a repeating bar. 7 and 5/6. This can be written as 5 divided by 6, 5 divided by 6. So 5 divided into 6 parts. I'm going to add some zeros here. Can 6 go into 5? Again, this does not change its value. Can 6 go in 5? 0 times. 0. How many groups of 6 go to 50? 8 times. remainder is 2, enter 0, bring it down. How many groups is 6 going to 20? 3 times. Remainder is 2, enter 0. How many groups is 6 going to 20? 3 times. Remainder 2. Wait, this is repeating. So add the repeating bar right there. Don't forget the whole number, 7 and 833 thousandths. Well, you know, if it can also be written as 7 and 8300 with repeating. Since it's the 3 that's repeating, not the 33, the 3 is repeating, you can just say put the bar on top of the 3 only. So, in our lesson today, we learned how to turn a fraction to a decimal. Again, use what you know about place value to help you out. For example, I see 0 in 20 hundredths. 20 hundredths can be simplified to divide by 10, 2 tenths, or 1/5. So these two match up. Another way you could do it, to turn a fraction to a decimal, you divide. 6 divided by 20, or 6 divided to 20 parts. So can 20 go into 6 0 times? Can 20 go into 63 times? So 30 hundredths and 620 are the same answer. This is decimals and fractions.